Hello students, this video is about extended triangle problems. It's the fourth lesson in the second unit, and we're going to be talking about what to do when you look at a problem, you look at a diagram, and you're not sure which of the different procedures to use. You're not sure whether to use the exterior angle theorem or the triangle sum theorem or supplementary angles, complementary angles, what have you. Your job is going to be to figure out which one to choose, and I'm going to walk you through the idea of, well, what do you need to do in the diagram, or what do you need to observe in order to make this decision? The target is very straightforward. I can apply angle relationships. Those angle relationships are the triangle sum theorem, the exterior angle theorem, supplementary angles, complementary angles, that kind of thing. The objective is going to be to calculate unknown angles. Most of these problems are going to have unknown angles in terms of x in triangles by solving linear and also quadratic equations. As a quick note, your teacher told you that before you can attend this lesson, you have to watch that short video on solving quadratic equations. It's something that you should remember from algebra, but obviously we understand that sometimes you might forget. So go ahead and watch the video on quadratic equations before you watch this video so that you know what we're doing. For the do now, it asks us to identify the method that we're going to use to solve the problem first, and then find the value of x. Just like we're doing a normal problem on the test, on the quiz, on the Regents exam, you would need to identify the method first, then set up an equation to solve. So let's take a minute to do that. Go ahead and pause the video, try to figure out which method you would use and why for each of these problems, and then come back to see if you got it right. All right, for this first one, we can see that we're talking about supplementary angles. The problem gives us two angles that are adjacent to each other, adjacent of course meaning next to, and those two angles form a straight line. What I can do with my highlighter is show you that this is the straight line that I'm talking about from here over to here, and then the split in that line is from here to here, which means that this angle here and this angle here add up to 180 degrees. That's what supplementary angles means. You could also think about this as a linear pair. For this next problem, it says we're going to be using the exterior angle theorem. We're using exterior angle theorem because the diagram shows one exterior angle, that's out here, and two remote interior angles. If you remember from last lesson, the remote interior angles are the ones that are not next to, not adjacent to the exterior angle. So we're going to be using exterior angle theorem for that one. And then for that last one, it tells us that we're going to be using the triangle sum theorem. In this triangle, we have one interior angle, a second interior angle, and then a third interior angle. All interior angles, unlike this one and unlike this one. So if you have all three interior angles, we're going to use that triangle sum theorem, which means that they all add up to 180 degrees. All right, now that we have some kind of plan under our belts, let's try to figure out what the equations look like. I'll go ahead and pause the video and try that out. Let's figure out what equations we're going to use for these problems. All right, the supplementary angles concept is that any supplementary angles, whether there's two supplementary angles or three or four or however many that make up that straight line, they're going to be equal to 180 when you add them or sum them together. For the exterior angle theorem, remember that it's exterior equals interior plus interior. These are concepts that you do have to memorize. You have to know what the exterior angle theorem is by the back of your hand. You need to know what the triangle sum theorem is, which indicates that the three angles in a triangle, the three interior angles of a triangle, are going to sum to 180. You need to be able to fill these out as well. So now take a moment to identify what pieces go into where into these equations. All right, hopefully this makes sense to you. We have those two interior angles, the two angles that form a straight line. They equal up to 180. And then in this case, we identified the exterior angle, which was 100, and the two remote interior angles, which are 2x plus 3 and 51. And in this case, we simply took all these angles, added them all up, and set them equal to 180. Now what we have to do is combine like terms, use inverse operations, just solve the equations just like you would solve them in a regular old algebra class. Go ahead and pause that video and try to solve each of these equations. I'll show the answers one at a time. All right, one quick thing to remember from algebra is when you're adding two expressions that are separated with parentheses, it's not necessary to worry about those parentheses. You only got to worry when this is a minus symbol, and then that subtraction would be distributed to the other terms in the second parentheses. But since we're just adding, we're able to combine like terms. 3x and 2x is 5x. 10 and negative 30 is negative 20. I don't have to walk you through this because you know it already. This is algebra. A long story short, you get x is equal to 40. Go ahead and try to pause that video and see if you can answer this second equation. This is a nice little algebra review. This equation was solved in a very similar way. In this case, I decided to take that 51 and subtract it from both sides first, and then move the 3 over using another inverse operations. I could have composed this into 2 different steps, combine like terms first to make this 54, and then subtract 54 from both sides. Regardless, I would have gotten x is equal to 23. Last but not least, that triangle sum theorem. Go ahead and try and see if you can combine all of those like terms and get the value of x. All right, sometimes in questions like this, I like to use the underlines method to keep track of all my like terms, right? I have 3x and x, that's a 4x, plus another 2x, that's 6x. And then this negative 17 combines with a positive 40 and a negative 5 to give me positive 18. Subtracting 18 from both sides and then dividing by 6 is going to give me the answer of x equals 27. Now, you might not have been able to figure out which method to use right away, but hopefully this helps you identify the clues as to which method goes with which type of problem. If the problem gives you 3 angles that have unknowns, variables inside of them, you're going to use the triangle sum theorem. If you have some information about an exterior angle and the 2 remote interior angles, it's going to be the exterior angle theorem. And even though there's an exterior angle here, I wasn't given remote interior angles. I was given the interior angle that was right next to it. So anytime you have 2 angles that are separated by a line or separated that create a line rather, those 2 angles are going to be supplementary. Fairly straightforward stuff as long as you are able to identify what's going on. Moving on to the wrinkle in this lesson, you do need to know how to use the quadratic formula. Remember that the quadratic formula's job is to solve a quadratic equation. In other words, get the roots of a quadratic equation. There are other methods to solve quadratic equations. You could use the factoring method. You could use completing the square. But I would say that there are 2 distinct advantages to the quadratic formula. The first advantage is that it is given to you on the Regents reference sheet. This is written down there so you don't have to remember it. The second advantage is that it will always work. Regardless of what quadratic equation they throw at you, it will always be able to generate 2 valid roots. Let's take a look at the model example to try to figure out when we would need to use that quadratic formula. It tells us that PR in this problem is extended to S, and the measure of angle P is equal to 110, which is labeled here. The measure of angle Q is 4x, which is labeled here, and the measure of angle QRS is x squared plus 5x. So you should already get some idea that we're going to take this x squared and put it into an equation, thereby making the equation a quadratic. What is the measure of angle Q? That's the main question, and we're going to try to figure out x first and then substitute it in there. So I got my little game plan. Now what I need to do is figure out which of the methods I'm going to use. Keep in mind that there are 3 different methods that we've talked about, 3 main methods we've talked about this lesson. We talked about supplementary angles, triangle sum theorem, and exterior angle theorem. In this case, we're given information about this angle and this angle. They're both interior angles. And we're also given information about this angle, which is an exterior angle. That should be the only clue you need. An exterior angle and 2 remote interior angles. We're going to be using the exterior angle theorem. I'm going to show the work here. I'm only going to show the first part of it, which is writing out the formula and then the substitution, because I want to talk very briefly about how to solve quadratic equations. All right, we set up the 2 remote interior angles, which are 110 and 4x respectively, on the right-hand side of the equation, and on the left-hand side we have x squared plus 5x. The idea behind a quadratic equation, when you're trying to solve it, is to make it say, or put it into the form of ax squared plus bx plus c equals 0. In other words, I'm not going to try to solve this for x, I'm going to try to solve this for 0, and then I'll be able to substitute the necessary values into the quadratic formula. So let's try to solve this for 0. In other words, let's try to get 0 on one side. I'm going to try to get 0 on the right-hand side because the left-hand side already has the x squared. That's where I want the x squared. All right, you should be able to follow my algebra here. We subtracted 4x from both sides, and then we subtracted 110 from both sides. Now we have x squared plus x minus 110 is equal to 0. Now let's identify the 3 values that we need in order to put in the quadratic formula. Remember, here's what the quadratic formula looks like. Remember, its job is to find the value of x by substituting b, a, and c into the formula. If you're not sure where b, a, and c come from, keep in mind they're going to come from the quadratic equation itself. If you'll recall, The quadratic equation is in the form ax squared plus bx plus c. So the a, the b, and the c are actually the numbers, or the coefficients in this case, of x squared and x, which means we have to identify what number is supposed to be here, what number is supposed to be here, and what number is supposed to be here. The c is very straightforward. The c value in this case is just 110, or sorry, negative 110. However, the a and the b value, since there's no number here, we have to do a little thinking. What coefficient does x squared have in front of it? And what coefficient does x have in front of it? In both cases, the answer is just 1. So the value of a is 1, the value of b is 1, and the value of c is negative 110. All right, let's start substituting that into the quadratic formula. All right, hopefully you're keeping track. The b value is supposed to be 1, so wherever it says b, I'm replacing it with a 1. Here's a b, so I replace it with a 1. The a value is 1 also, so wherever I see an a, I'm replacing it with a 1 here and here. And then the c value is negative 110, so I've substituted in here. I only have to substitute in c once. Now I'm going to start simplifying by evaluating the stuff that's inside of this square root. Take a look at that step. This is a little bit more cleaned up. You see negative 1 plus or minus 1 squared is just 1. Negative 4 times 1 times negative 110 is positive 440. And then I did 2 times 1 on the bottom. That's just 2. Now that you get to this stage where it's a little bit simpler, we don't have a lot of operations going on here. It's just the square root and then 2 individual numbers. What you can do is take this plus and minus and actually split it up. Keep in mind that the original equation, which was a quadratic equation, had an x squared in it, which means in general there are going to be 2 solutions, 2 roots. So in order to find those 2 roots, what we're going to do is take this and split it up into negative 1 plus square root of 441 over 2, and also negative 1 minus square root of 441 over 2. Both of those are valid answers. Here's what it looks like. All right, here I made the split, negative 1 plus, and also negative 1 minus. Now we're going to evaluate the square root. The square root of 441 sounds bad, but it actually turns out to be an integer. Looks like we're getting closer and closer to an actual answer, negative 1 plus 21 over 2, and negative 1 minus 21 over 2. Now we simplify the numerator and divide. All right, finally, after long years of waiting, we finally found our answers, which are x equals 10 and x equals negative 11. Keep in mind, this is a geometric problem, a problem that deals with actual physical measurements. So one of these values is going to work, but one of these values is not. Let's take a look back at the diagram to see which one works and which one doesn't. Remember that what we're going to do is take this x value or this x value and substitute it into the expression, specifically into this expression for angle Q and this expression for angle QRS. What if we took this 10 and substituted into the 4x? Well, we'd get 40 degrees. What if we took the negative 11 and substituted in for x? We'd get negative 44. It turns out that negative 44 can't be the measure of an angle, right? You can't have a negative angle measure. So we're going to eliminate this one. This value is not going to be a value that we could possibly use. And we have a special term in geometry for a value that we can't use. We call this an excluded value, which means there's only, at the end of the day, there's only one correct answer, which is x equals 10. Now that we have that, we can find the measure of angle Q very easily. And we find out that the measure of angle Q is equal to 40 degrees. All right, that was the video on extended triangle problems. Remember, the focus was identifying the different theorems that we're going to apply to each problem and then solving the problem. Good luck studying.